Hello again, everyone. Today we're going to start looking at how to solve word problems with the vertex form of quadratics. So once again, the vertex form of quadratics looks like this. So that's y is equal to a times x minus h squared plus k, where the a controls whether the parabola is stretched or compressed and whether it's right side up or upside down. The h controls how the parabola moved left or right, and the k controls whether the parabola moved up or down. Now, you don't actually have to have each one of those numbers, because sometimes the numbers will be either 1 or 0. So, for instance, if k was 0, the k wouldn't appear in the equation. And that's what's going to happen in this first example here. So I just took this example out of the textbook. It says, the curve formed by the cables on a suspension bridge can be modeled by the relation y is equal to a times x minus h squared, where y is the height above the bridge deck and x is the horizontal distance from one support tower, both in meters. So, first thing it says is, what is the vertex of this parabola? Well, we'd have to count all the little lines. So if I count them by twos, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So this is at number 28 along the x-axis. This is where 0, 0 is. So the parabola has moved to the right by 28 meters. Okay, so the coordinates of the vertex of the parabola are 28 and 0. And we know that when you have the coordinates of the vertex, that actually gives you the h and k value of that equation. So already I know that my equation is going to be y is equal to a times x minus 28, because it's going to the right by 28. If you remember, I always have to use the opposite sign that we assume would be moving to the right. Okay, plus k, which is plus 0, which means I don't even have to write the plus k. So that's going to be my equation so far. Now it says determine an approximate value of a. To do that, we need to pick another point on the parabola. Now, with this particular picture, it might look like it's difficult to figure that out. However, one very important point that is given to us is right here. Now, we haven't talked too much about that point this year so far, or within this series of videos, but that is what's called the Y-intercept. Now, the Y-intercept is a beautiful point to use because its x-coordinate is 0, right? You haven't moved left or right to get to that point. All you've done is moved up. So how far did we move up? 1, 2, 3, 4, 5, 6, 7. So the y-intercept is at 0, 7. So how do we use that to find our a value? Well, as I've discussed in a previous lesson, you take the x and y values of your other point. Now, why am I saying other point? Because you can't use the vertex in this step. We've already used the vertex to find our h and k. We can't use it again to find our a value. Okay, so this is our other point, which we're going to use the y-intercept because it's such a nice point to use. Let's substitute the x and y into the equation. Now, be very careful when you do that. It's confusing because the x is first in the coordinate, but the y is first in the equation. So we have to use the y value first, and then we're going to put the x value in. Now watch what happens when I put that x value in there. You can see that the x value is actually 0 minus 28 inside that bracket. So that just simplifies to negative 28 squared, right? Because 0 minus 28 is just negative 28. So the x value doesn't, we don't even need a calculator up to this point. Now I am going to have to next square negative 28. Now when you square a negative number, you always get a positive number. So be sure you do that on your calculators correctly. So I'm just going to do it off screen. and that gives 784. Now this is still a multiplication, right? So how do we now get rid of a multiplication? We're trying to get a by itself. We've got to get rid of that times 784. Well, that means dividing both sides by 784. Oops, wrong line there, sorry. And that means our a value is going to be a decimal, 7 over 784. So again, I'll take out my calculator. Now you could leave it as that fraction. You could. Or you can write it as this decimal that we're going to get, which is 0.009 for our a value. And that was b in the equation. Now C says write an equation for the quadratic relation that models the parabola. Well, now that we know our h and k and our a value, we know that the equation that models this would be 0.009 times x minus 28. Now I went back to x instead of using 0 here because our final equation should have y's and x's in it, to the power of 2. Now just to show you what that would look like, let's switch over to our Desmos app and actually graph it. So we would have y is equal to 0.009 times x minus 28 bracket I should use the keyboard on the screen, to the power of 2. Now we can't see the full parabola here, so I'll zoom out. And that would be the parabola that would model, that shape should match the shape of that bridge. Now you'll notice that we have extra pieces here, right? We had said that the, let me see here, if I zoom into the Y-intercept, see how the Y-intercept is at 0.7? Oh, it's not quite at 0.7. You know why? Because we had to round off that a value a little bit. Okay, if I actually used here, let me try this just to show you. This is the issue with rounding. But if I used 7 divided by 784, which was the fraction that gave us that decimal, now look, now it's right at 0.7. Okay, so the rest of this parabola on this side doesn't mean anything because the bridge doesn't continue that way. But this is the equation that models it. So same thing at the other side at 7, which is right there. The rest of the parabola doesn't mean anything. Okay, so there's ways in math of saying only use this part of the parabola, but we're not going to get into that this year. So let's move back to our whiteboard here. Okay. So it says, based on your equation, at what height above the deck are the cables attached to the support tower? Well, we've actually already figured that out. That would be our 7. Right? We can look at that right from the graph. So there is a way of doing it from the equation, finding the y-intercept. But I don't think I'm going to show that right now. So we'll just wait for another example for me to show that. Okay? So here's example 2. So it says the human immunodeficiency virus, or HIV, the virus that causes AIDS, is a global concern. In an effort to combat the spread of HIV in the United States, the Department of Health developed a prevention program. So we have a table that shows the number of infants with HIV born each year from 1985, and we also have the graph of that table. So the relationship between the number of infants with HIV and the number of years since the start of the program appears to be quadratic. So would there be a way that we could model this scenario using what we know now of our quadratic equations? Okay, so let's try. We've got, so the first thing we've got to do is we've got to, okay, so what is our equation? Our equation is this. So is there a way that we could estimate where the vertex would be on this parabola? So the parabola is coming up through these points here. What would you think would be the maximum height that that parabola would reach? So if I was doing this, I would probably estimate 800. Now the problem is, where does 800 occur? Well, we kind of need to know what this scale is to be able to estimate what this middle point is here between the 5 and the next line. So what is the scale? The scale is every 2 squares is 5, which means every square is 2.5, which means what would be the middle of 5 plus the next step over, which is 7.5, right? So we'd have to add the half of 2.5 to 5 to figure that out. So if this is 2.5, what's half of 2.5? Well, half of 2.5 is 1.25. So this point right here would be at 6.25. Okay? So we're saying that the parabola's vertex moved over by 6.25 and up by 800. So this is our k value, and this is our h value. So if I substitute that h value in there, remember if it's moving right, that inside the bracket it should be negative, so that's going to be negative 6.25 squared, and then plus 800. And now we have to calculate our a value. Now to calculate our a value, we need one of the other points to use. Well, look at here. We've got another y-intercept that we can use, okay? So what is the coordinate of that point? And you can actually see it in the table to be more precise. It looks like it's at 200, but it's actually a little bit above 200 at 210. So this right here is our y-intercept. Now how do we know it's our y-intercept from the table? If we didn't have the graph, how would we know? Well, all y-intercepts have an x value of 0. So that's how you can tell in the table that it's your y-intercept. So I'm going to substitute 0 in for x, 210 in for y, and the rest of my equation looks the same. Okay, so just like before, we now have the 0 minus 6.25 in the bracket, which is very easy to simplify. It just becomes negative 6.25. All that is squared. And now we have to start working our way to isolating a. So when you isolate a variable, you work your way outside in towards that variable. So the first thing we're going to move is that 800. So where's that 800 going to go? So we're going to have the 210 over here. That 800 is adding on this side. When we move it over to the other side, it's going to subtract from 210. So I'm just going to erase this now. So we're going to have minus 800 on this side equals a times negative 6.25 squared. Well, let's do the 210 minus 800 first. Just going to do it on my calculator off to the side to make sure I'm not making any mistakes. So that's negative 590. Now let's square the negative 6.25 at the same time as we did that. Again, just going to do it off to the side. So that gives 39.0625. Okay, and we've got one more step to do. We've got to get the a all by itself by getting rid of that new number that's multiplying it. Well, to get rid of a number that's multiplying, we divide by that number on both sides. So this now cancels out, and we've got our a value, which is going to be equal to the answer to that. So we've got negative 590 divided by 39.0625, which gives 15.104 negative. And we now can write the equation that models this scenario as negative 15.104 times x minus 6.25 squared plus 800. And that should be a pretty good model for that relationship. Now, why would we want to do that? Well, this graph finishes at year 13 right here. Okay, what if we wanted to find out how it would look like at year 15? So instead of waiting for year 15, projecting in the future, which is called extrapolation, okay, so I could ask you to extrapolate to predict the number after 15 years. So how would we do that with the equation? Well, our x-axis, if you look, is the years since 1985. So the equation and the graph are exactly the same thing, so that means the x value here is the number of years. So I can substitute our 15 years in here, right there where the x is, do the math to calculate how much that would be, and I will do it on the calculator here. So I think I will show you this calculation so you can see it happening. Just trying to rearrange things on my screen here so I can see everything I need to see. Okay, so let me clear out everything that's in the calculator. Now I'm going to do this all in one step here. We've got, and this is the way I have to type it into this calculator, 15.104, and that's negative, so I click the negative button after. Some calculators do it before. Times, bracket, 15 minus 6.25, close the bracket, square that answer, plus 800. And we're getting a negative number, okay? So that means that at 15 years, there's actually no more infants, because you can't have negative infants, all right? Which is a good sign, right? Because they're not getting infected anymore, or there aren't as many getting infected anymore, okay? So, so that's something that you can now do. You can predict future values of what's going to happen with that equation. Okay, let's move on to the next example. A football is kicked and its path can be modeled by h is equal to negative 0.1 times d minus 5.6 squared plus 6, where h is the height of the ball and d is its horizontal distance, both in meters. What is the maximum height of the football? Now, when I'm working with a question like this that I kind of know what it's going to look like, I like to draw a little sketch of the picture to help me kind of visualize what's going on. So the football is going to be kicked, okay? We're going to give it a projectile trajectory here instead of being kicked straight up in the air, which could happen as well, but because they're telling us there's a horizontal distance, I'm assuming that the football is traveling this way as it's being kicked, okay? So what is the maximum height of the football? Well, the maximum height is right here. But what do we call that point on a parabola? That point is called the vertex. So if I had a way of finding the vertex, I could answer this question very easily. But I do have a way of finding the vertex. This is in vertex form, right? This is in the form y is equal to a times x minus h squared plus k. And we know that the vertex is h and k, where the h is how far over the vertex has moved from 0, 0 to the, in this case, to the right, because if I actually drew this on a graph, 0, 0 would be here. Okay, I actually don't know if that's where the parabola starts, all right, but I do know that the parabola has moved to the right by a certain amount, all right, because of that number. So if I fill in my h and k values here, the k value, remember, tells you how high the parabola moves, the vertex moves, sorry, upwards. So what is my k value? My k value is 6. So how high is this parabola at its maximum? It's at a height of 6 meters. Because that vertex has to be the maximum height. So there's very little math to do there. In fact, I wrote down a lot more stuff just to explain it. You could have just told me, well, from the equation, the maximum height has to be 6, because that's the height of the vertex. Now we also know it's a frown-shaped parabola, because it's a negative a value, which is why I drew it upside down. But if you think of a football being kicked, that's obviously the trajectory it's going to follow. Now here is a question that I said a few minutes ago that I was putting off for a little bit. It says, from what height is the ball kicked, or what is its initial height? This is the Y-intercept. This is the way that questions will ask you to calculate the Y-intercept, because the ball was kicked from what time value? So the time value when it was kicked is always 0. If you think of a stopwatch starting at the beginning of an experiment, it's always starting at 0, right? So that is going to be the initial height. Now I don't know how high that is. That's what we're going to calculate. How do we calculate it though? Well, this is our, oh sorry, I actually made a mistake here. Let me correct this. We're not talking about a time value here. We're talking about a distance, okay? So what was the starting distance? Our starting distance was 0. I made a mistake because oftentimes with parabolas, you're talking about a time value. In this case, it's a distance value, which you can see right here, okay? So sorry about that. So at a distance of 0, which is our starting distance, how high up was our parabola? Well, let's use our equation to figure that out. So I'm going to rewrite it here. Because my memory's so bad, I'm going to have to keep looking. D minus 5.6 squared plus 6. So if d equals 0 on the graph tells us our starting height, that means that d equals 0 in our equation is also going to tell us our starting height. The equation and the graph are the same thing. So let's substitute 0 in for d. And you'll notice that this is different than what we were doing before when we would substitute a value in here. Before, we were actually finding our a value, but we know our a value here. The only thing we don't know is the h value, so now we're going to be finding that h value. So I just have to type all that into my calculator. Now I'm going to make my life a little bit easier. Because this is a 0, I'm just going to simplify that. Okay, remember, this is still very similar to what we just did finding our a value, but we're not finding a. We're finding h this time because we already know our a. All right, so what is our starting height? So if we type this into the calculator, which I'll just do off screen if you don't mind in this case. So we've got negative 0.1 times bracket negative 5.6 bracket squared plus 6. And that's height. That height is 2.86 meters. Now, if anybody knows football and you're thinking of a kicker on the field, this is not a kicker on the field, okay? This is somebody playing with a friend off of the edge of a hill. Let me do that a little bit better here. Okay, so they're off the edge of a hill, almost 3 meters up, and they're kicking the ball down to a friend on the bottom of the hill. Okay, because if you think of a kicker on a football field, they're almost right on the ground. The ball is actually usually held by the, I don't know what the guy's name is, but the person who holds the football for the kicker, and sometimes the ball is put into a little cup that holds the football a little bit high off the ground. But here, this is not that case, okay? And we've just mathematically proven that. So this is the height of our y-intercept. We subbed in 0 for d, and we found our y-intercept. Okay, so if you ever have a question that's asking you, find the initial height, or find the initial value of a quadratic, you're usually subbing in x equals 0, or in this case, d equals 0, to find that value. Okay, let's look at another one. The manager of a hockey arena is pricing tickets for an upcoming game. She knows that if she increases the price of the ticket, she will sell fewer tickets. This situation is modeled by this equation. R is equal to negative 110 times P minus 10 squared plus 10,500, where R is the revenue and P is the price of the ticket. What is the vertex of the parabola, and what does it represent in the context of this question? So once again, we're looking for a vertex. We're asking for h and k. So h would be minus 10. Sorry. See, I just made the classic mistake. H is not minus 10. H is plus 10, because you always do the opposite of what's in the bracket here. Okay? Plus 10,500. Oh, not plus 10,000. Sorry. When we're using the coordinate system, we don't put a plus, we just put a comma between the two. Okay? So this is our h, and this is our k. And we now know that our vertex is at 10,500. That's the maximum height, right? What does it represent in the context of this question? Well, in the context of this question, the 10 is how far over we've moved our price. Okay, so we've increased our price by $10, and the 10,500 is what is the maximum revenue. So 10,500 is the maximum revenue when the price is increased by $10. And I know this is A, and I did have a question B, but I think I'm going to leave that question aside and just end the lesson there. I think you've seen enough now to be able to do the questions that you're going to encounter in the homework today. I cannot show an example of every different type of word problem that you're going to encounter, but they're all almost always going to be talking about, you know, either calculating the equation given the vertex, find the vertex to tell me what the maximum either height or price or number of people are, and you kind of have to read the question and figure that out. Okay, what are they asking you for in that equation? So if you do have any questions with the homework, please let me know, and we can definitely discuss it. But that's it for today, folks. Have yourselves a great day.